We've looked a lot at the sort of surfaces that come from quadratic equations in 3 dimensions, but there's actually one other kind of surface that is relatively straightforward to understand sort of what shape it makes and why. And that kind of surface is what's called a cylinder, not just a circular cylinder that we're used to, although this is of the type that we're going to talk about, but more general cylinders. So let's sketch the graph of this equation, z equals y cubed. Notice that what makes this equation interesting is, well, maybe the first thing that you notice about it anyway, is that there's no x in this equation, right? And this will be the case for all of the types of surfaces that I'm talking about. So for our purposes, what will make a cylinder will be an equation with one variable missing. Okay, so that's going to make a cylinder. So the trick I'm going to show you for understanding what surface this makes, this trick will work for any equation where one variable is missing. Okay, so z equals y cubed. Well, if we look at, right, we have this, our way of understanding 3D shapes is by slicing them. So let's slice this in the x equals 0 plane. Okay, the x equals 0 plane is going to look like this. Okay, and we'll also slice it in a few other planes with constant x value, as we usually do, say the x equals 1 plane and the x equals minus 1 plane. Okay, so to do that, the x equals 0 plane, let's turn the plane so that we're looking at it head on. Okay, so now this is the y direction, this is the z direction, and this is the plane x equals 0. So we don't have an x-axis because we pulled out this one plane from our stack of planes here. So on this yz plane, we can just graph this graph, right? Because this equation doesn't have an x in it, we can pretend that this equation is only in the yz plane. If it's only in the yz plane, we could just graph it. So z equals y cubed, that's going to look like, right, the cube function looks like this. Right. So that's the shape we get in the plane x equals 0. So let's draw that over on our x equals 0 plane. Drawing it with the correct perspective is going to be a little difficult, so if it doesn't look convincing, I'm sorry. Something like this. Okay. But now what about the x equals 1 plane? Well, the thing about this equation was that there was no x in this equation. So if we come over to our picture and change this x equals 0 to an x equals 1, it'll be the same picture, right? Because changing x does not change anything about what this equation says. So the cross-section in our x equals 1 plane will be exactly the same cross-section. But that's also going to be true for the x equals minus 1 plane. It's going to be true for every plane. So what we get is this plane that looks like our graph, except it's been sort of slid sideways like this. Right? So every cross-section looks the same. And this is what a cylinder is, right? A cylinder is a shape where a circular cylinder is a shape where every cross-section is the same circle. Our more general cylinder is just a surface where every cross-section is the same shape, whatever the shape of your graph is. So let's look at one more example. Maybe how about I need to choose an example that I can actually draw a convincing picture of. What I want to do is something like y equals sine x. I'm not sure I'm going to be able to draw a convincing picture, but let's try it. Okay, so notice this is a cylinder because there's no variable z in this equation. So we can figure out, what does this look like in the xy plane? Well, it looks like the graph of sine, which looks like this. Okay, so now we can take a stack of planes perpendicular to the z-axis. So let's only draw a couple of them. We know ahead of time that all of the cross-sections will look the same, so we don't need a ton of cross-sections since they all look the same. At least 2 is nice, though. So we're going to draw this graph in each of these planes. And I'm going to try to get the perspective. So something like this. Oh, that worked pretty well. And then the same shape over here. And then join these up. Right. And then in the back, boy, I don't know how to, does this, I don't know if that helped or not. Okay. Okay, so that's what our surface, our cylinder looks like in 3D space. So generally, I think this would get called the cylinder. Cylinder starts with a C. This would get called the cylinder over y equals sine x. And just from the context, it's understood that the direction that the cylinder is going in is the z direction, right? So we started with a graph. We just take that graph and slide it in the remaining direction, and that produces our cylinder.